There we go. Okay, so there's the first question. The first one's actually kind of a weird one. Find the function that is finally graphed after the following transformations are applied. Okay, so basically we start with y equals the absolute value of x. The first thing is they say go right 3. So when you go right 3, how do you know? Well, first off, what do you think it does to go right 3? What am I going to do to that equation to go right 3? Am I going to put like a plus 3 in there, or am I going to put it like out there, or is it minus 3 in the absolute values or out of the absolute values? Yeah, very good. Yeah. Do you guys get the hang from the videos or the problems or whatever? That anything inside the whatever, in this case it's absolute values, anything inside the parentheses or absolute values or square root or whatever function you look at, anything inside the thing with x is going to have an x effect, a right-left effect. Anything outside, like this second one that's outside, that would be an up-down effect. So that's how. So first off, we know, okay, it's going to be in the absolute values because it's an x kind of thing, and then and x always does the opposite. Did you catch that other thing? Y does normal, but x does opposite. So minus 3. You know, that's opposite of how we would normally think. Huh? Normally minus we would think would be left, but it's actually right because x does the opposite. Yeah, good. So that's the first step. Next one, they say stretch vertically by a factor of something I can't read. Factor of 3. Stretch vertically by a factor of 3. So vertically is a y thing, isn't it? It's an up-down thing. So stretched means multiply by 3. When you add or subtract numbers, that moves the graph. When you multiply or divide, it stretches it or compresses it, either horizontally or vertically. So they're saying vertical stretch, so it's going to be a 3 out there. Does that make sense? Because it's outside, it's not inside the absolute values. It's not an x thing. It's a y thing. So anything outside is a y thing. Anything inside is an x thing. It's a y thing, and it's times for a vertical stretch. And then next it says down 2. So now we're moving it. We're moving the whole graph. We're not stretching or compressing. We're just moving the whole graph down 2. So what's good? So that was vertical. This last one, vertical stretch times 3. And now down 2. That would be minus 2 out here, huh? Down 2. Again, that's a y thing, so it's outside the absolute values. And it's down to minus 2 because y is normal. Negative is down, positive is up. Okay, the last one, here's the trick now. Reflected across the x-axis. Reflected across the x-axis. So the x, if you think about what that means, here's the x-axis. And they're saying reflected across. That means the x-axis is like a mirror, and you're going to reflect across it. Kind of like, so the x-axis is a mirror, and you're going to reflect across the x-axis. And so what that means is we're actually doing up-down movement, aren't we? Even though it says x-axis, it's really a y thing, isn't it? Because the x-axis is the mirror. We're going across the x-axis. So you got to watch out for that trick. Because to trick you by saying x-axis, but it's really a y thing. Okay, what makes things like flip or reflect? Multiplying by -1. Yeah. So what am I going to multiply by -1? X or y? Is it actually in the end a vertical thing? Yeah, it is. So it's going to be y by negative. That's the trick. You got to do the y by -1, not the x. I'll fix it in a second some other way. But first off, that is true. And if you gave me that answer on exam, that'd be correct. That'd be full credit. So that's true. But that doesn't look like any of the options. So I've got to do something to that to know which multiple choice option to grab. But does that make sense first off that it's y? Because it's really a vertical flip, isn't it? Flipping the x-axis being the mirror is a vertical flip. -1 on y. Now, these answers don't have negatives on y. So I've got to get rid of that negative so I know which multiple choice answer to choose. So let me bring it over here. -y is 3, absolute value of x minus 3 minus 2. So to get rid of that negative, what I'm going to do is multiply both sides of the equation by -1. That'll get rid of the minus. It's plain old y. And I'll have minus parentheses 3, absolute value of x minus 3 minus 2, like that. That shows me that it's option, I think it's option C, isn't it? Yeah, see how it's option C there? Whoops, I kind of one over the top of it. It's option C. Like that. You don't have to leave this minus out here. I mean, you could distribute that minus, but I'm just making it look like option C so I know which one to grab. Is that good on that? That makes sense? You're already comfortable with that, or?
I actually would like us to go over it because I get kind of confused towards like left-leaning.
Yeah, it's a little tricky, huh? Okay, let's take a look. So, what we need to do on this one then is the main thing that I suggest is look at these numbers. Those tell you the walls which separate the sections of the graph. That's what a piecewise, this is called piecewise because it's in 3 different pieces. Does that make sense what the description is saying? It's saying you use the x plus 3 function when you're in x territory between -8 and 4. Jumping down to the bottom, you use the x minus x plus 7 function when you're in x territory to the right of 4. And in the middle, it's just when x is 4, it's just at -9, period. So let me show you more detailed what that means. Put a wall at -8. So I would go over here and go. Now that's not really an asymptote line and not really required, but I've noticed it helps students. So I'll go ahead and put a wall at -8, and I'll put another wall at 4. -8 and 4. And I'm putting those in because those are the separators. And now, where am I supposed to use the x plus 3 function? In what section? Left, middle, or right? Yeah, it'd be the middle for x plus 3 because it says when x is between -8 and 4. And then to the right of 4, it's supposed to be the -x plus 7. See how I put those up there so I know which ones to use in which sections? And then in the middle, right when x is equal to 4, right on the money, it's just at -9. And by the way, f is y. Function values, f, g, h, whatever, those are just y. So that's really saying y equals -9 when x equals 4. So that's actually literally telling me the point for -9, x, y. So that means over 4 down 9 is about right here. Whoops, didn't do that very well. But right here is over 4 down 9. So that's a solid dot at over 4 down 9. That's what that's saying. The other two I'm going to have to make tables for. All right, so let's make those tables. So for this one, I'm going to make an XY table for this middle section. And this is for the equation y equals x plus 3, which is in the middle. Now, how do I know what I should put into that table? Well, x plus 3 is a linear kind of equation. Does that make sense when I say linear? Linear means x and y to the first power. It means the picture is going to be some kind of a straight line. So whenever an equation just has x and y to the first power, we call that a linear equation because the picture is just a straight line. And if it's just a straight line, well, then all you need is 2 dots. So really, for this x plus 3 function over here, all I need is 2 dots to get a good picture of the line. So what 2 dots should I choose? You should choose the 2 edges of the wall. So the -8 and the +4. You can choose other points as well, but why bother? We only need 2 points, and we have to do the edges, so we might as well just do those 2. Now, it would be right for you to look at that and go, no, wait a minute, Mr. Herring. It says x less than 4 for that. Not equal to 4. You can't do 4. So this is where which is true, but it's infinitesimally close to 4. In other words, it gets to 3.999999. It basically gets to 4. So I put 4 on my table and I circle it to remind myself when I do find the point there, it's going to be an open dot because it doesn't quite hit the 4. But you don't want to make the mistake that I've seen many students make over the years. They'll go, oh, it's less than 4. You here for a pre-calculus review? Then this is the place. So when they'll say, well, x is less than 4, I'm just going to stop at 3. But that's not good, right? There's a lot of numbers between 3 and 4. You want to basically do 4 because it's 3.99999, you know. Circle the 4. All right, plug into the table. What do we get? -8 plus 3. What's that? -5. and then plug in 4. I'm just plugging in the x values, the 8, negative 8, and the 4 to the x plus 3 function. And what do we get there, 7? So negative 8, negative 5, kind of running out of room here. It's about right there, isn't it? Negative 8, negative 5. Okay, and now I'll do the other one. Pre-calculus review.
Yeah.
This is the place. All right, so we got that dot, and then the other dot is over 4 up 7. So let's find it. Over 4 up 7, right about there. There's over 4 up 7, and then just connect them. Everybody see what I got there? So that's that section. We got to do the right section now. So now for the right section, I'll come over here and do the right section. So over here, I'll go XY chart again. And for the right section to the right of 4, I'm just going to plug in 4 and then any other number you want. How about 5? It doesn't matter. So I'm just doing the wall at x equals 4. So everybody see how I'm doing that? I'm doing the right section now, which is the function negative x plus 7, because that's what it said. Negative x plus 7 is for x values greater than 4. Right? So when I'm to the right of 4, I'm going to do the function negative x plus 7. So now so I'm going to choose 4. 4 is on the wall. You always want to do the walls, the separating walls. Again, you might say, no, Mr. It's greater than 4. You can't do 4. You better start at 5. Don't think whole number-ish like that, right? 4.0001 is, so it's basically 4, right? But circle it. I do need to circle it because it's not 4 right on the money. That circle tells me open dot on the graph. And then why did I choose 5? You could have picked any number you want. I just add 1 because it's easy. Anything to the right is fine. Plug into the function, negative x plus 7. What do you get? Negative 4 plus 7. What's that? 3. Keep it circled. That's over 4 up 3. It's about right there. And then over 5, plug in 5, negative 5 plus 7, 2. Over 5 up 2. It's about like right there. So there they are. Here I'm running out of room for everything. So that one was, I'm trying to squeeze everything in there. That was 4, 7. And then this blue one is, what is it? 4, 3. And the other blue one is 5, 2. And we connect the dots. And there we go. There's our graph in the 3 different sections. The left, or I guess it's kind of like the middle, and then the wall, which has the solid dot at 4, negative 9, and then the right on that. So that's how you do piecewise. You just do them in the various sections on that. All right, we better move on. If that seems confusing, check back. This will be on YouTube. I'll put this up on YouTube later. You can check out how the beginning of that. All right, so let's take a look. So what you get a 3x5 card, right, during the test. You can have a 3x5 card. Write anything you want on both sides of a 3x5 card. What would be good is to write those basic 6 graphs that we memorize. Like the u squared, have the basic x squared, y equals x squared, and then y equals square root of x, and then right here is x cubed, and then cube root of x, which is like the sideways snake, right? And then the other 2 are absolute value of x. And the last one is 1 over x. That one's kind of funny. It has asymptote lines and branches in the diagonal corners like that. So those are the 6. You'd want to have those basic 6 on your 3x5 card, or maybe you already have them in your head, So so x squared and x cubed. X squared is a U shape. Square root, I always call that the firework. It's like it sits, because it's x, square root of x just stops on one side. Goes to the other side, doesn't go the other way. X cubed is a snake. Cube root of x is a sideways snake. And then absolute values of v and 1 over x has the asymptotes with the branches. Okay, so coming over here, we're supposed to find the central point and one other point. So that's exactly what this is exactly how the real test will look. And so what that means is you just make a little XY chart, and you're going to plug in, you're going to find 2 points, and the first one is going to be whatever, let me erase this, whatever makes the central point. So I have room down here, here we go. So central. How do you find out where the new center is? Do you guys know what I mean by that? Like all these 6, they all are centered at the origin, even this one, right? Centered at the origin, centered at the origin, centered at the origin, centered at the origin. All of them have their middle originally at the origin. But these graphs are going to move. So how do you find out where the new center is? Do you remember? Yeah.
Don't you use, like, wouldn't it be on x2? Wouldn't it be on positive 2?
It'd be actually -2.
Oh, okay.
It's whatever will zero out the x zone. Yeah, I don't know if you saw that on my other lectures. I mean, I'm sure you saw a lot. Hard to keep it all straight. Yeah, it's whatever, so let me write that for you. The center is what makes the x zone. Now, what do I mean by the x zone? 0. I mean, like, in this case, the parentheses, right? Sometimes it's absolute. In the next problem, it's the square root. It's whatever's in x's little world. Not the stuff outside of the root or parentheses or absolute value or whatever's x's little world. It's whatever's right in there, in the parentheses or in the whatever, with x. So make his little world 0. Other stuff, just leave it be. But make his little world 0. That will always tell you where the new center goes. It's a really easy way to find it. So, all right, so what could I plug in to y equals negative x plus 2 cubed? What could I plug in there will make this little world 0? Well, -2. And then y will just be -2 plus 2 cubed be 0. And now after you get the central point, that always tells you the new center point. Then how you get the last point is you just add 1. You can do other things. You don't have to do this, but this will usually be the easiest thing to do. Is that making sense? So you find the central point, and then next you just add 1 to whatever your first x value was. You just add 1 to it. So that'll be -1. Right? I took -2 and I added 1. And now plug that in. What are we going to get? -1 plus 2 cubed. What is that? Negative something. 1 cubed. So just -1, huh? Just -1. So I've got a couple dots. Let me go up here and put them on the graph. So back 2 up 0 right there, huh? Back 2 up 0. And then the other dot, is it back 1 down 1 is right down there. So back 2 up 0, well, and this one is back 1 down 1. Okay, so I'm ready to graph now. All it takes is those 2 dots, and if you know these basic 6 graphs, the basic shape, you know, from just those 2 dots, you should be able to put it together. This is x cubed, so he's the snake graph, huh? And now, let me show you a couple mistakes I've seen. I was just grading tests just today. Here's a mistake. People go like that. They go, oh yeah, snake. It goes through those 2 dots, it's snakes. That would be if it was cube. That's the cube rooter, not the third power. That's the third rooter, not the third power. Notice both the root graphs go mostly sideways, and the power graphs, x2 power, x3 power, go mostly up and down. Right? Does that make sense? It's about concavity. Have you ever heard that word before? As you go into calculus, you're going to be dealing with concavity more. What concavity is the way a bowl would face. So notice how the root graphs, the third root, square root, they're like a bowl turned down. Or in this case, a bowl turned up. Slow growth, in other words. Slow growth, mostly sideways. The square root, see, it's going up, but it's not going up very fast. It's a bowl turned down up there. Whereas look at the x squared, it's a bowl turned up. Look at the third paragraph. Bowl turned up when it's going up, down when it's going down fast, going up fast, huh? Concavity, the bending of the bowl. That does matter. So if you gave me that kind, I would probably take 2 points off. You'd get 4 out of 6 if you did it that way. Because you have a lot of stuff right, but you got the wrong bending. A bunch of my students just did that on the test. And I gave him 4 out of 6. So, so don't do that. Instead, look, go, oh, he's the third power. He goes like that through those 2 dots. Was there a question?
Oh, no, yeah, that's what I was going to ask. Like, since it's negative, it would just reflect. It wouldn't be like that, just transferred over to 2. It would reflect because it's negative, right?
Yeah, yeah. So if you want to talk about all those other things, we can do that as well. The table is easier. But yeah, if you want to talk about that what happened is with that equation, you're right. That negative in the front, well, first off, the x plus 2, that moved the thing left 2 units. That's why it's right here instead of at the origin. And then this negative in the front turned the graph upside down. Because normally, see the normal third power one right here goes lower left to upper right. This one goes upper left to lower right. He's been turned, we've took him and turned him upside down. That's what that negative did in the front. When I first semester I taught this material, I would just teach everybody to learn really well the movements and the flips. But then I noticed that was just hard for students, especially when 2 or 3 of them all get together in one thing. It's hard to tell what they're all going to do, and I started going to this table thing. I think you'll find students did a lot better on the test when I did that. So I think you'll find the table method a lot easier than trying to think out all the flips and the movements. Just so everybody get an idea of the table thing, just find the new center. How do you do that? Whatever will make the x zone 0. Plug that in and get your y value by plug it in, and then add 1 and plug that one in. And you'll have the center point and one other, and then it'll be easy to put the graph. Let's try it on number 6 there. I'll go to a new screen here. Okay, so number 6. Let's try that. Let me give you a second. Try that same process. XY table. Y equals square root of minus x plus 2 with a plus 3 on the outside, or minus 3 out there, huh? We're good there. So first thing is you got to choose an x value. You want to find the central point. You want to choose an x value that'll make that little world 0. X's world is the root in this case, right? This is X's little world right here, that little root. So what can you put in for X? The negative is already there. The plus 2 is already there. So what do we put in for X to make that little root thing become 0? Just the root. Now don't worry about the negative 3, just the little root thing. Just 2, right? Is that making sense? If you just simply put in 2, then this will be, the negative is already next to the x, so that'll be next to our 2. We'll get 0 minus 3, we'll get negative 3. 2, negative 3. I did make x's world 0. It didn't make the whole thing 0, right? I'm just making x's little world 0. That will be the new middle point, the new center point. Everybody seeing that? So again, it's not making the whole thing 0. It's just making x's little world 0. In this case, the root. Sometimes it's absolute value. Sometimes it's whatever. Parentheses. So that's the new center. Over 2, down 3. Let's put that on the graph. There it is right there. Over 2, down 3. That's the new center. So the center is normally at the origin, but it's moved over 2 and down 3. Now how do we find our second point? What do we always do? Once we have the center point, what do we always do to find the second point? Add 1. This is the one and only time it won't work. And it turns out we'll have to subtract 1 instead of adding 1. So I wanted to show you this. Otherwise, it always works. Just add 1. Whatever your first x value, just add 1. It'll work great. This is the one and only time it won't work. And I'll show you it won't work. And then when we see it doesn't work, we'll go back and say, all right, instead of adding 1, let's go back to the 2 and subtract 1. That's what will work. So if adding 1 doesn't work, subtract 1. Anyway, let me show you it doesn't work. You probably have already seen it. Exactly, and that's imaginary, huh? You can't root a negative number. Yeah, so if you plug in 1, you're going to get something. What are you going to get? Square root of negative. Oh, what? I was supposed to plug in 3. What am I doing? I'm getting confused. So I added 1 to the 2, and I get 3. So I'm plugging in 3. So negative 3 plus 2 is negative 3. That's the root of negative 1. No. I'm just going to write no, and I'm actually going to go to the graph and go over 3, no. That's important information. At over 3, no, because that's imaginary. That means the graph is telling you, I don't go there. I don't go there. I don't go to the right. So where must he go? He must go to the left. We already know that, but let's find it. Let's find the particular. Is that one okay? Does everybody see why that was a no? Because when I added 1 and I got 3, and I plugged in 3, I got the root of -1. You can't root negative numbers imaginary. So I just said no. Okay, and so instead of adding 1, this is the one and only time you have to, instead of adding 1, you have to subtract 1. So my original value of 2, I tried adding 1, got 3, that didn't work. Said subtract 1, now plug in 1. So what are you going to get? Root of -1 plus 2 minus 3. What's that? Root of 1 minus 3, 1 minus 3, -2? So over 1 down 2. There it is. There's the dot. Over 1 down 2. Everybody seeing that? Got our 2 dots? All right, are we ready? So now we're ready to graph. Now, what does this graph look like? It's a square root graph. What does the square root graph look like? Well, he's the firework. He's the one, the reason I call him firework, it looks like 4th of July or something, where you put a firework on the ground and it shoots off. And he's special because he's the only one that doesn't go left and right. He only goes one way. So he's got a stopping point, in other words. He's the only one that stops on one side. All right, so let's connect the dots, though. You ready? I'm going to do it wrong. You can probably tell by my tone. Here's what I see. I just graded my other class's test, and there was like 5 people or something that did it. They go like this. They go, let me see if I do it wrong. Okay, they go, here we go. Yeah. Whoop, whoop, I'm doing something crazy. They go, here we go. Yeah, there we go. Got it. That's wrong. Why is that wrong? I made a root kind of graph. I connected the dots.
I thought the origin.
Yeah, they started with the wrong one. That's why the center's so important. Who's the center? Him. You got to start with him. He started with the other one. You got to start with the right one because he's only going one way. So you got to know who the starter is, or you're going to get it the wrong way. Remember, we already said it doesn't go right anyway because of the no over there. So we know something's wrong. So yeah, let me go back. Let me put these dots in. Hello. What's my thing doing? Oh, there it is. Over 1 down 2. Over 2 down. Yeah. So you got to be clear. That's why I would just put a C by the center one, because he's the starter. You got to start from him. He's the new center. So if you start from him, yeah, then it must go left like that, huh? That's the correct graph. By the way, don't make it bend up. That's the other mistake I see, right? Remember, root graphs are slow growth. They mainly go right, left. It's bowl turned down, slow growth. Don't make it bowl up. It's not a power function. It's a root function, right? Does that make sense on that? How to do all that? So you'll have 3 graphs on part 1. Basically, your part 1 test will be 3 of those graphs. That's all part 1 will be. That's the part you cannot use your graphing calculator. You can use your graph calculator for everything else. So part 1 will be simply 3 of these graphs. You can use a regular calculator if you want and crank out the graphs. Turn that into the testing people or to me if you come to take it with me tomorrow, and then I'll give you part 2. You can do the rest with your calculator. Question?
I'm a little confused. You said that y equals square root of x only goes right with the firecracker, but this one it went left.
No, it only goes one way. It can go right, it can go left, it can go right down, left down, depending on whether it's flipped or turned. You know, any of these graphs we can flip them and turn them and reflect them and move them, but it's only going to go one way. It's not going to go 2.
I had a question.
Yeah.
For y equals 1 over x, even though there's no part of the graph that's on the central point,
Right.
you said
That's still its middle. Even though it doesn't touch the origin, the crosshairs is still its middle. Yeah. And that one gets tricky. We'll do a lot more with that in the second part of the course, in the next part. Yeah, and you'll see in the videos I'll be talking about it because that's a good question. I would talk about it more right now. I'm tempted to dive in there, but there's other things I won't get to, and it's not going to be tested heavily on this test. I'll just be straight with you. But on the second, it will. So definitely spend some more time because you're right, because it's one of the most interesting ones because it doesn't actually touch the middle. But the crosshairs are the middle. And so I talked on the YouTube about how you find the new location for the crosshairs is what you do when he moves. But don't worry about it a lot for tomorrow's test. But when we get into the exam 2 material, we'll bring it up again and we'll talk more about it. Okay. All right, so there it is. So basically, they're wanting us to work backwards, meaning they're giving us the picture on number 7, and they want us to come up with the equation. So, like, let's do this one first off. How do we take him and find the equation of this piece of a line there. How do you work backwards from a picture to an equation? That's what they're wanting me to do. Well, it's a straight line, so it's y equals mx plus b. You with me? That's how line equations always are. Remember that from your algebra days? Can we figure, what does the m stand for? Slope, rise over run. Yeah, comes from some French word, mountainous thing. But yeah, you're right. I mean slope or rise over run. So can we find the slope of that line? There's two ways you can do it. You can just kind of look, just eyeball it, rise, run, like that. Here's the rise. Here's the run. Yeah, it looks like up 4 over 3 by just kind of looking at it. Is that good enough? We can just do that. 4/3 x plus. If you want to be more formal about it, you could do the formula, the y2 minus y1 over x2 minus x1. If you're not sure, just looking at it's good enough. You could do the official, and this is like x1 y1 x2 y2. You could do y2 is 4 minus y1 is 0 over x2 0 minus 3 is 4 over 3, same answer. So either way, by formula or by just looking at the picture, rise over run is slope. Okay, that's all good and everything, but how do we find the b now? Now I need the b. What's the b? Does anybody remember from algebra?
-3.
That's the y-intercept, right?
It's the y-intercept, it's right there. There's the b, it's the 4. Yeah, the b is the y-intercept. So I'll just write that, y-intercept. It's where your line hits the y-axis up at 4. And so we got that equation. That was good. And then you would do the one on the right the same way.
So there'd only be two piecewise functions on that one?
There's just two pieces, yeah. Yeah, you want to do the one on the right? Here, let's do the one on the right. Let me get this stuff out of the way here. You can look back at the YouTube if you didn't get it down. Okay, so let's do this piece. So y equals mx plus b, because he's a line as well. So what's his slope? Slope is rise, run. So what's his slope?
3 over 3, so it would just be x, wouldn't it?
Up 2 over 3,
Oh,
right? It went up 2 and over 3. That makes sense? Rise over run, x, plus, everybody good with that so far? What's his b?
2. 2.
Okay, remember what b is. Here's the y. I'm not doing that very well. Here's the y.
Oh no, it's the origin.
Yes, here's the y-axis. Here's the line. Where do they meet? Right there at the origin 0. Remember, b is where the line hits the y-axis. So that's the b. It's at 0. And the other b was whatever, 4. So there we go. So how do you do the final answer then? You say y equals, or f of x. I really don't care. I'm good with either one. And one of them is going to be the 4/3. 4/3 x plus 4. And the other one is going to be the 2/3 x plus 0. I'll just skip the 0. But then you've got to give the x region for each of those. In other words, I've got to say x between a couple of numbers and x between a couple of numbers. Well, how do you know which numbers? Well, you go back over to the picture, kind of erase all the mess here, and you ask yourself, this line here exists in which x territory? This is the x-axis, right? From here to here. That's the x territory. What is that? That's -3 to 0, isn't it? -3 to 0 for that one. Everybody see that? That's what a piecewise function means. You tell which pieces exist in which x territories. And how about this piece on the right? This piece, what x territory does he exist? Well, x 0 to 3, huh? 0 to 3. Does that make sense on that? So we're done with that one. Questions I can answer? Now, having done that, can I give you a trickier one that is on the test? I'm sure I'll have your attention with those words. So on the test, I realized, and at the last minute, I lectured to my 2 face-to-face class. Feel free to drop by my face-to-face, probably. That's why you're taking online, because you don't want to come to a face-to-face, but that's okay. If you ever want to, you can. The times are on WebAdvisor, feel free to come by. But I put the lectures online anyway, so I'm not sure why you'd want to bother. So anyway, what I showed my face-to-face at the last minute before the exam is, what if I give you a line that doesn't hit the y-axis, which I did on the test. And so I felt nervous. I hadn't prepared people for that, so I showed them at the last second. So let's just do one right now. What if I give over 2 up 1 and over 7 up 3, or, whoops. Oops, got a little trouble with the thing here. Anyway, what if I did that? So, could we do the y equals mx plus b for that? Can you find the slope first off? So the slope, the m, is going to be like the y. You can just kind of eyeball it or formal it. Use the formula if you want. So what would all that be? This is x1, y1, x2, y2. Yeah, 3 minus 1 over 7 minus 2. Yeah, 2/5. We good with that part? Now, so that was normal enough. Now the trick, how do you find b? How am I going to find b when it does not hit the y-axis on the graph, right? It stops right here. Because normally we would just, see where the line runs into the y-axis, but that one doesn't. Does anybody remember from your algebra days how you would possibly find that b when the line, what can we do? What could we do with those points, for example? 2-1 or the 7-3. Remember this from algebra? If you plug in either one, just one of them, 2-1, or you could do the 7-3. Remember, this is x, this is y, right? So plug the 2 in for x, the 1 in for y. Then you could solve for b. That's what you have to do when the picture doesn't show the line hitting the y-axis, doesn't hit the middle line. I'm going to finish that up, but everybody still see what I'm doing? I just plug, so you could do the 7-3, it'd work just as well, give you the same exact answer. Grab either pair of points, because if a point is on the line, you can always plug it into the equation. It's always allowed, it makes the equation true. So what are we going to get? Remember how to do like a fraction times a whole number? 2/5 times 2. Remember it's over 1 and becomes 4/5. Like that. Good to there. Got to solve for b. You guys like fractions? You can use your calculator. Subtract 4/5 from both sides. Boom. So b equals, what is 1 take away 4/5? I had 1 whole pie and somebody ate 4/5 of it. What's left? 1/5 of the pie. So b is 1/5. So we found it. The equation is y equals mx plus b. It's y equals, what was it, 2/5? X plus 1/5. We found the equation. So that's on the test. A piece of a line that's not hitting the y-axis like that. So the only new part was after we found the slope, to find the b, we had to plug in one of the points and solve for b. Good on that? All right, I'm going to pull it off and move. Okay, so 8 is just fractions. That's easier said than done. How do we solve fractions? You guys remember? It's like a flashback from algebra. Do you know you want to find the LCD and multiply it all the way through by the LCD? And anybody know the LCD? Remember how you just multiply the denominators together? 2 times 7x, 14x. So the LCD there is 14x. I'll do it right over here. LCD is 2 times 7x, 14x, and then what you do is you go 14x, 14x, 14x. That makes sense? Top, top, top. You got to do equal treatment, right? Both sides of the equal signs. So they were equal before, you treat them the same, they'll be equal after, right? And then remember how that works? You're supposed to cross cancel whatever can cancel the denominator, you do it, and whatever's left over after the canceling multiplies. So 14x, the first one just multiplies. 14x times 1 is just 14x. 7x goes into 14x 2 times, and the leftover 2 times 6 is 12. Am I going too quick? Do you see that there?
I'm not really sure, where did you get the 14x from?
Yeah, I multiplied the two denominators together.
Okay.
2 times 7x, got 14x.
Okay.
Yeah, so that's how we find a common. You just take all the denominators and multiply them together, and then that'll be a common denominator. It has them all. It's common. You make it out of all of them. And then you multiply it to the top of everybody, and then you cancel. So remember, that's the keep in mind what we're even doing here. What are we doing? We're trying to get rid of the fractions. We hate them, right? Most students I work with do not like fractions. We're getting rid of the fractions. So don't forget to cancel. That's exactly what it's supposed to do right there. We're canceling those off. 7x went into 14x 2 times, and the leftover 2 and 6 multiply to be 12. And then over here on the right, can you do that one? So go ahead and cancel the denominator, because that's really a 14x over 1, isn't it? So cross cancel. So 2 goes into 14 7 times. What's left over, 1 times 7, and the x as well. Don't forget the x is left over, whereas the x canceled in the middle, didn't it? Everybody see that? And now, no more fractions, huh? Much easier. What do you do when you have x's on opposite sides of the equal sign like that? Yeah, subtract one of them. It doesn't really matter which one. I'm going to do do the x's first. Yeah, don't worry about the 12. Do the x's first. Boom, that's gone. Minus 12 is, what's that, minus 7x? So get the x in just one location. And now how do you get that x alone? Divide. Boom. 2 negatives make positive 12 sevenths. Now we're done there. Questions on that one? Good. No questions? I can clear it off there. Is that okay? Okay, let's do those absolute. Okay, so let's do the absolute values now. So, absolute value less. So this one is absolute less. And this one will be absolute greater. Do you notice that? In fact, you know what, guys? Let me just give you a game plan. How about this? I'll just go to a new screen and go absolute less. Oops. Absolute less. So if you have like the absolute value of sum inside plus whatever, 5, less than or equal to 8 or whatever. And then I'll come down here and do absolute greater. Absolute value of sum inside. I'm just going to give you the general rule here. Plus 5 greater. Okay, so let's talk about the two different setups and how we handle them. Okay, so how do we do absolute value of the inside plus 5 less? So the first thing in both cases is just get rid of that number in the front. You know, you don't want that thing there. So just get rid of that. Good to there. And now we do something with that. How do we do it? Well, you have to make it a triple. You remove it. Just notice removal. Or removed. Just say removed. Removed the absolute values. See how I removed the absolute values? There's no longer an absolute value on that inside, is there? That's what happens when you remove. You have the -3 and the +3. I don't want that to be some step like monkey see, monkey do without any reasons. Like, just think logically. What if I said, hey guys, I'm thinking of some number, and the absolute value of it is less than 3? Just be real with me for a minute. What could that number be? What number could that be? The absolute value of it's less than or equal to 3. Doesn't it have to be 3 or 2 or 1 or 0 or -1 or -2 or -3? Anything in that region. The absolute value of all those numbers is less than or equal to 3, huh? Not 4, not 5, 6, and not -4, -5, -6. The absolute value of them is not smaller than 3. It's bigger, right? So that's what it means. Whereas over here, it's going to be fundamentally different. If I said, hey guys, I'm thinking of some number and the absolute value is greater than 3, which is what we're going to have on the other one in a minute. Let me just precurse ahead of time with some logic. What does that mean? That number's got to be 3 or bigger, or -3 or smaller. It's the opposite, isn't it? If the absolute value of the number is coming out 3 or bigger, it must be 3 or bigger, or -3 or smaller. Huh? It's the two outsides for absolute value greater, isn't it? It's the two outsides. For absolute value less, logically, that means the middle section, doesn't it? See the difference? So that's what this is. This is in the middle. The inside, the number inside must be in the middle between -3 and +3. Do you see that logically? So, so let me get rid of all this stuff. You can look at it later if you want, but get rid of it and come on back here. So what I'm saying is, you do this and then ... and I'll work the other one out for you too, but that's the main step. I would put that on my 3x5 card for the exam tomorrow. That's the main step. When you remove those absolute value signs, they logically mean the numbers between. It's in the middle for that kind. And now for the absolute value greater, again, you would, whoops, got the wrong color there. Oh, come on. So again, the first step is to subtract the 5, and we have the absolute value of the inside greater than or equal to 3. Then the remove the absolute values. What do you get? You remove them and you say, okay, that inside, remember what we said? Less than or equal to -3, or the inside is greater than or equal to +3, isn't it? See how it's 2, and you go ... just solve those 2. It's the two outsides, huh? So that's what you want to have in your 3x5 card. Know the correct way to remove. Let me say a word. When I grade your exams, I'm pretty lenient with like silly little mistakes like adding. Sometimes I'll give you full credit even. Wrong answer, but you just added wrong on the last step. I'm pretty casual about that. Maybe 1 point off, maybe even full credit. But conceptually is what I'm looking for. Are you getting the idea? Is the idea making sense? So like I said, a little adding, subtracting doesn't bother me. We all make mistakes that way. You have calculators, you can use them. But if you get one of these symbols turned the wrong way, you're really not getting the concept. So like if you just turned one of those symbols the wrong way, but all your adding, subtracting was perfect, you'd probably get a 0 on the problem. So I want you to know what matters and what doesn't, so there's no surprise. Make sure you take careful note of the way those symbols are facing. It would make all the difference in the world if this thing was turned the other way. Or if you made a greater become the triple inside, or a less become the 2. No, that's the whole thing. That's the whole ball game. That's the logic. That's what you have to get. That's the big concept. So any absolute value less needs to become a triple with the thing inside. That's just what it means, as I showed you on the number line. That's logical. Absolute value greater, what it means to be greater means to be the two outsides with the or. The two separate statements, left and right on that. So you can't flip those around, or you're really not getting the big idea. Make sense on that? So make sure you write that down. You have in the card, you can write that exactly as you see it. So we can go back now, and let's solve that problem. Okay, so let's do this one. So is that an absolute value less or greater? It's less. And notice number 10 is a greater, and that's what I'm going to give you on the exam. No surprise. I'll give you one less, one greater. All right. This one doesn't have any number we have to get rid of first. Number 10 does. Number 10, here, I'll do the first step on number 10 right now. We got to add 2 to both sides, huh? Anytime there's a number, get rid of that number right away. So I'll just do the first step on number 10. I'm gonna go back to number 9 now. So on number 9, I'm ready for the removal phase on number 9. So yank off those absolute values and carry, just think, and if it helps you, let me do this. Let me cross this off and just say number. Just think logically. Logic is always better than memorization in math science. It really is. I have a terrible memory. I never could have made it through my classes in math science if math and science was about having a good memory. It's not. It's about the logic. If you can get the idea, you'll know what to do. You won't need somebody to tell you something to memorize. You'll understand it. If I said, hey, the absolute value of some number smaller than 7, what does that mean? That number must be between -7 and +7. That's what it means for the absolute value of something to be smaller than 7. So I go, oh, that just means it's between +7 and -7. I don't need to memorize anything. That's what it means. So then it's just 2 minus 3x. I mean, call it number, call it Joe, call it Tom, call it 2 minus 3x, whatever. The thing is between -7 and +7. Because the absolute value of it is smaller than 7. That's what it means. Right? That makes sense? Whereas the other one, and I'll finish that in just a second. The other one, yeah, you say the absolute, you have a cross, the absolute value of something is bigger than 7. What does that mean? How can the absolute value of a number come out bigger than 7? How can that be? Well, that number, that thing, call it 2x plus 9, call it Joe, call it Tom, call it number, must itself be, well, you could do it either order, it doesn't matter, smaller than -7, like -8, -9, -10, or it's bigger than 7, like 8, 9, 10, and on up you go. That's what it must mean, logically, right?
Can you still solve with those?
Yeah, I certainly will. Yeah, so now, let's look at this one. So I know it's still kind of, it's not simple from there.
No, I mean, I know,
Oh.
it wasn't asking you to solve it, it was more like, oh, but you could still like solve it, like you -9 minus 9.
Exactly. You're thinking totally right. So let's do that. Yeah, once the absolute values are out of there, which they are now, you just do normal algebra steps. But I know that's not, that's good to go over that too. So what would we do first? So the absolute value part is over now. There's no more absolute values anywhere. We're done with absolute values. Now it's just normal. How do you solve what's called a compound inequality from algebra? Well, all your focus should be right here. Don't even look at the ends. Who cares? We're looking at x, right? And x is saying, I want to be alone. Get rid of this 2 and get rid of that 3 so that I can be alone. Right? So who do we get rid of first? Do we get rid of that -3? No, he's right next to the x. You save the stuff right next to x for last. First get rid of the -2, and it's a triple, right? So whatever you do to one part, do to all 3. So this is -9, this is gone, this is 5. And now last step, get rid of the -3. How do we do that? Divide. Whenever you divide by the identical twin. Same sign, same everything. And does anybody know? You gotta do something special when you divide by a negative. You gotta flip the symbols. You divide it by a negative on both sides of both symbols. You gotta flip them. Yeah, whenever you divide by a negative, you gotta flip the symbols. Remember that from your algebra days? So we get this. This is +3 because this is -9/3. Yeah. Everybody see that? There's the answer to that one. And that's fine with me if you want to leave the answer that way. It kind of bugs most people to have the smaller number on the right. Negative is smaller than the positive. It's right. What it says is true. But if it bugs you, just go ahead and grab the whole thing and turn it around. Symbols, numbers, letters, everything. Give it a flip. And it'll say the same truth in a more readable way. That's the same. That's saying the same thing, isn't it? Meaning x is a number between -5/3 and 3. How about the other one? How do we solve this? Well, this is 2 separate, so we'd subtract 9 from both and divide by 2. So x is less than -8, like that. And then over here, subtract 9, divide by 2, x is greater than -1. So x is less than -8 or greater than -1. It's 2 outsides, right? I just solved them. So this is solving 2 separate, notice. And this is solving a triple. Less thans are always a triple. Greater thans are always 2 separate. Well, we are past 4 o'clock. And have we finished? I think we finished part 1, right? 10 questions. 10 questions, yeah. Right, so we're gonna stop there. I covered part 2 on the YouTube stuff. So